Yeah. Okay. So good evening, everyone. Good afternoon, everyone. I am Shivani, and I welcome you all for the final summary session for the course of Digital Signal Processing. For this summary session, I had requested you to put on your doubts in the Ask a Q&A section of the portal, and I received a lot of queries in that. So I saw that around 29 to 30 questions were asked in that mail, but it's very difficult to cover it in 2 hours duration. And I saw that most of them had detailed solutions available. So what I'm doing in this session is the questions which don't have detailed solutions, like only for which the options were listed, I'll solve them in this particular session in the interest of time. And few questions which are too lengthy, I'll give hints about them so that you can try it. I am talking about the same questions, Sujata. So whatever you had posted around 29 to 30 questions, it's not possible to solve all of them in this 2 hour session, and I can't take more sessions due to my other commitments. So because of that situation, I'll be taking only those questions whose detailed solutions are not available, and one or two questions I won't be able to solve in this session whose solutions are not there, but I'll definitely give hints about them at the end of this today's session. So let's start. So assignment 1 didn't have question solutions, detailed solutions. So I'm taking the questions which you have highlighted in that. So first one which you highlighted was this fifth question. So it says that which of the following is true about the Fourier transform of g prime t, the periodically repeated version of time limited function gt with period t naught. And this is a multiple answer correct question, and it has the following four options. So the first option is it depends on t naught, second one is includes direct delta function, then third is it is the periodically repeated version of g of f in the frequency domain, and the fourth option is it is the sampled version of g of f in the frequency domain. So what is given to us is we have some signal gt, and this has its Fourier transform g of f, and this g of f is given by integral minus infinity to infinity gt into e power minus j 2 pi f t dt. This we can also write as, since it is a limited function, time limited function, and it is repeated with a period of t naught, so we can safely say that from minus t naught by 2 to t naught by 2, this signal will be there. Or let's assume that the signal lies in this region. So here what I'm saying is, let g of t be non-zero for all values of t belonging to minus t naught by 2 to t naught by 2. It will be less than that, but at least for this region let it be. Or let it be like this only. Okay, then it is said that I have, okay, one more thing I will like to mention, that this could be something like this also, where Tm is less than or equal to T naught, so that equally spaced, like periodic repetitions will not overlap. That kind of situation can also happen. And even if this is true, this integral still makes sense because all the other values of t, it will be 0. Now what is mentioned is g prime t is the periodically repeated version of this time limited function gt. So this g prime t I can write as summation k running from minus infinity to infinity g of t, and this is repeated at every time instance of t naught. So minus k times t naught. So this thing here is periodically repeated version of GT. And let's say that let G of f, or rather G prime of f, be the continuous time Fourier transform or CTFT of G prime t. Now one thing we should notice is G prime t is a periodic signal. And for a periodic signal, CTFT is obtained with the help of its continuous time Fourier series coefficients. So let AK, where k belongs to the set of integers, be the Fourier series coefficients Therefore, this G prime of f, or capital G prime of f, is given as summation k running from minus infinity to infinity ak into delta f minus k times f naught, where f naught is 1 by t naught. So this gt is basically having a period of t naught. So its fundamental frequency will be 1 by t naught, which is f naught, and therefore this impulse here will be repeated at every integer multiple of f naught, and it will be scaled by this ak. So now let us find out AKs. So by definition, these AKs are obtained as 1 upon T naught integrating over a period. So let's say from minus T naught by 2 to T naught by 2 G prime T into delta T minus, e power minus j 2 pi f naught k t dt. Now in this region, from minus t naught by 2 to t naught by 2, this g prime of t is equal to gt. So this thing is equal to gt in minus t naught by 2 to t naught by 2. Why? Because it's given that it is a time limited function. So therefore, this ak will be equal to 1 over t naught integral from minus t naught by 2 to t naught by 2 g of t into e power minus j 2 pi f naught kt. Okay, so this is what we are having right now. So now what we will do, we'll take up this ak and substitute in this equation. Okay, so therefore let me number. So let's say this is equation 2 and this is my equation 1. So now we'll substitute equation 2 in equation 1. Therefore, this g prime of f, which was equal to summation k running from minus infinity to infinity ak into delta f minus k times f naught, this comes out to be equal to summation k running from minus infinity to infinity. This ak is this equation here, which is 1 over t naught integral minus t naught by 2 to t naught by 2 into g of t into e power minus j 2 pi f naught kt dt into delta. So this is my ak, and now I have this impulse f minus k times f naught. Okay, now this integration here is a function of simple time, and this is a function of frequency only. Now this thing here, the frequency comes up here only. So now note that, just focus on this part. Okay, this thing I can write as e power minus j 2 pi ft into delta f minus k times f naught, which will give me, by the property of impulse, this f I can replace by k times f naught. So this will be e power minus j 2 pi k f naught t into the impulse. So these two quantities, this one and this one, are exactly same. So therefore this thing, since it is getting multiplied by this impulse, I can simply replace by this quantity here. Okay, so therefore I can write this as, I can take this 1 by t naught outside. So 1 by t naught summation k running from minus infinity to infinity integral minus t naught by 2 to t naught by 2 gt into e power minus j 2 pi ft dt into delta f minus k times f naught. Now look at this part, this green color highlighted part, and observe this thing here. So this thing is exactly my capital G of f. So therefore this green thing which I highlighted is simply my G of f. Okay, so now I can write this as 1 over t naught summation k running from minus infinity to infinity G of f into delta f minus k times f naught. Okay, so this I can also write as 1 upon t naught G of f into summation k running from minus infinity to infinity delta f minus k times f naught. This thing here is a train of impulse in frequency domain. We are multiplying a train of impulse to a function of frequency, which means that this entire operation here is equivalent to sampling in frequency domain. So this entire operation here is like sampling of G of f at f equal to k times f naught, where k belongs to the set of integers. Okay, this is the first observation we are having. Now let us go back to the question which we had and look at the last option. So this Fourier transform of g prime of t, it is said that it is the sampled version of g of f in the frequency domain. So yes, but it is little bit scaled, but still it is a sampled version of g of f in the frequency domain, and therefore this option is correct. Now another thing is, it depends on t naught. So let us observe the final expression. So now you see this part, here we have t naught, and also this f naught is 1 by t naught. So therefore from this part and from this part here, what we have is f naught is 1 by t naught which clearly implies that depends on T naught, and therefore this first option is also true. Second option is it includes the direct delta function. Okay, so now we are having the entire train of impulse here. So here this one is simply the train of impulse. So this gives us the dependency on direct delta function. So this depends on direct delta. So therefore this second option is also correct. And the third option is it is a periodically repeated version of g of f in the frequency domain. So if you observe carefully, this g of f is not getting repeated at every integer multiple of this f naught. What is happening is sampling. We are not at all having any repetition of this g of f, which means that no periodic repeatedness is coming up, and therefore the third option here is not correct. So by whatever we have solved just now, first option, second option, and this fourth option, that is A, B, and D, or 1, 2, and 4 are correct. Is this part clear? Is this question clear now? Okay. Okay. If this is clear, then let's move on to the next question. This is also from the week 1's assignment. This is question number 7. So it says that I have shortened the question. So it says that the system for which input output relation is given. So what is given is this x of n, or rather x1 of n has an output y1 of n, x2 of n has an output y2 of n, and x of n will have an output y of n, and it is given that the system is shift invariant. So it's given that this system is shift invariant, and it is also given that this for all x of n, which is equal to x1 of n plus x2 of n, output is y of n, which is equal to y1 of n plus y2 of n. And then it is said that the system is linear and shift invariant. So whether this statement is true or false, that we don't know. So it is given to us from question that it is shift invariant. So shift invariance is given to us. Another thing given to us is this thing. Does this tell me anything about linearity as a whole thing? No, this is just claiming additivity. So this statement here is just telling me that the system is additive. But so the system is time invariant, so we need to check linearity. So for linearity, the system should be one additive. This thing is given and it is true. And second thing is homogeneity. And for this thing, nothing is given, and we cannot say anything, or rather we cannot claim that it is homogeneous. And since we can't say this thing properly, so from the given information we can't say that the system is homogeneous, and therefore we can't say that the system is linear, and hence we cannot say that the system is linear and time invariant. So since system may not be linear, it is not LSI, and therefore this statement which is given to us is false. Is it clear now? Yeah. Okay. So if it is clear, then let me just move on to the next question. So yeah, this is a very simple question. Like this proof is not taken in class. This was given as a challenge in the lecture. So just don't bother regarding the proof of this. But this was mentioned in the lecture, in some lecture in week 1, that when I'm having sampling, I have aliased versions coming into picture, and these multiple copies lead to constructive interference at every integer multiple of sampling duration, and a destructive interference at all other time instances. So this was not something that you need to figure out on your own. This was just given to us. So just refer to the lectures once, like especially those challenges which are given to you now. So these are like a trick questions. They can come in MCQs. So just look at them. I purposely put this in the slide. So I'll just put a note here that refer to the statements of all the challenges or all the challenge questions. It's there in your notes. It's there in week 1 lecture. So just look at these kind of statements. These can come in your MCQs. I don't know if they will come, but yeah, may come these kind of questions. Okay, so now let us move on to the next question. So week 2 and week 3 detailed solutions are available. I won't go into it. This is week 4. For week 4, there were no detailed solutions given. So that's why this is question 2 which you had asked. So this is a simple question. You just have to apply the definition of DTFT. So what is given to us is a signal x of n, which is 1. Question 10 of week 1. Did you ask for it? I don't know. 5, 7 and 8 were asked, I think. Anyway, let's just finish off these questions, and then if time permits, I'll get into it. For -3 less than or equal to n less than or equal to 3, and it is 0 otherwise. Okay. Okay, I'll just quickly check what was question 10. If it was a simple thing, then I'll just mention how to go about it. Otherwise, we'll see what to do about it at the end of the session. because weak one is probably the easiest one which we have. And just open whatever you have mailed. Okay, so this question, I'll give a hint about it. So you have like your eyes are capturing image signals and it has a like retency of 1/10 of a second or something like that, which means that every 10 hertz it will refresh. So when you're seeing a video, if the frame sampling frequency is less than 20 frames per second, you will see some sort of breaks and other kind of things will happen. So now if your sampling frequency is less than your Nyquist rate, then aliasing will happen, otherwise aliasing will not happen. So now just look, consider this and check the sampling frequency or the whatever persistence of image criteria we have, and based on that just check which uh, options are correct. So these are just based on persistence of image thing, which is 1/10 of a seconds. So 30 fps is a good sampling rate. So based on that, you can look at the things. It just depends on that. I hope this will help you to solve that question. Okay, so in this question, sorry I missed out on that question. I didn't look only. Okay, so in this question, x of n is given as 1 from -3 to 3 and it is 0 otherwise. So this x of omega is given as, by definition, it is summation n running from -infinity to infinity 1 into e power minus j omega n. This thing I can write as, so this signal is 1 from -3 to 3, it is 0 otherwise, so I can just make this n running from -3 to 3 1 into e power minus j omega n. So now this thing here is a geometric progression, and its first term is e power j omega 3. Its common ratio is e power minus j omega, and number of terms is 7. So therefore x of omega is equal to first term into 1 minus common ratio to the power number of terms divided by 1 minus e common ratio. So this is e power j3 omega into 1 minus e power minus j7 omega upon 1 minus e power minus j omega. So this thing, from the numerator I can take out common e power minus j 7 by 2 omega. So this will be e power j3 omega. From numerator I am taking out common e power minus j 7 by 2 omega. So I will be left with e power j 7 by 2 omega minus e power minus j 7 by 2 omega divided by, from the denominator I can take out common e power minus j omega by 2. So I'll be left with e power j omega by 2 minus e power minus j omega by 2. Now I can divide and sorry, I can divide numerator and denominator by 2j. So now let us first figure out this thing here. So I'll have e power j omega, then it will be 3 minus 7 by 2 plus 1 by 2. Then here I can write something like this. I'll have e power j 7 by 2 omega minus e power minus j 7 by 2 omega divided by 2j, and this thing entirely I can divide by e power j omega by 2 minus e power minus j omega by 2 upon 2j. This thing here will be equal to sine of 7 by 2 omega. This thing here will be equal to sine of omega by 2, and this thing here reduces to 0. So this entire e power j 0 will be equal to 1. So this comes out to be equal to 1 multiplied by sine of 7 by 2 omega upon sine of omega by 2, which is simply sine of 7 by 2 omega upon sine of omega by 2. Is it clear? A similar thing is solved in lectures also. I think that is for a general thing, more general thing. This is for x of n equal to 1 from -3 to 3. Okay, so if it is clear, then let's move on to the next question. This question is quite interesting, and I'm glad that you asked. It is an important thing, a good application of Parsifal's theorem. And I forgot to mention here that this sinc of x is defined as sin x upon x. Yeah. Okay. So now just consider this thing here. So the integral that is given to us is integral minus infinity to infinity sinc square kx minus c dx. Now what I'll do is I'll do change of variable like this. I'll do substitution. Kx minus c equal to t. Therefore k dx equal to dt. Now since this x is running from minus infinity to infinity, this c and this k are real constants. Therefore this t will also vary from minus infinity to infinity. There won't be any change of limits. So therefore now this thing now will become this dx I can replace as, so this dx is equal to dt by k. So I can replace this dx as 1 by k into dt, integral minus infinity to infinity sinc square t dt. Okay, now just number this as equation 1, and everything is happening in, let's say, continuous time. So now one small thing that I will like you to keep in mind is, if this thing here is a rect function, this will have a Fourier transform as a sinc function. I won't derive. Okay, so this is in frequency domain, or let's say in angular frequency. I won't derive its equation. And similarly, if I have a sinc in frequency domain, time domain, then I'll have a rectangular function in frequency domain. So this is what comes when you solve. This is a thing that you should keep in mind in general. So now what we'll do is we'll take up this thing. Why? I'm having this sinc of t here. So this thing here I can write as 1 by sorry, this thing here I can write as 1 by k integral minus infinity to infinity sinc of t into sinc of t dt, which is equivalent to, or which is equal to, integral minus infinity to infinity mod of absolute value of this thing. So this equation here is equivalent to this thing also, because sinc is a real function. So this is something like this integral here this integral here is like integral minus infinity to infinity magnitude of x of t square dt, where x of t is sinc of t. Okay, so this is what I'm having currently. So let's say that this is my x of t, and I'll have its equivalent x of omega, and for that let's take, I don't know what coefficients are there and what's happening. So for that what I'll do is I'll take a very generalized case that this has an amplitude of a, and it varies from minus b to b. It will have an amplitude of a and it will have an amplitude of 0 otherwise, or rather x of omega. So what I'll consider, so since we know sinc in time domain gives rectangular function in frequency domain consider a very generalized case where x of t, this is a sinc with some constants multiplied and something happening, have a Fourier transform x of omega as a for omega belonging to minus b naught by, sorry, minus, let me define it in another line. So this x of omega is equal to a for minus b by 2 less than or equal to omega less than or equal to b by 2 and 0 otherwise. Now let us find out x of t. What is the exact expression for this x of t? So this x of t is equal to 1 over 2 pi integral minus infinity to infinity x of omega into e power j omega t d omega. This is the standard definition what we have, and we'll substitute this x of omega in this equation now. So this is equal to 1 over 2 pi integral, this ranges from minus b by 2 to b by 2. In this range it is a into e power j omega t d omega. Therefore this x of t is equal to a upon 2 pi, and integration of e power j omega t will be e power j omega t upon jt from minus b by 2 to b by 2. This comes out to be equal to a by 2t, 2, so I'll just, okay, a by 2 pi into e power j b by 2t minus e power minus j b by 2t upon jt. I can rearrange it a little bit and I can write it as a upon pi t multiplied by e power j b by 2t minus e power minus j b by 2t upon 2j, and this thing here is equal to sine of b by 2 t. So now this x of t is equal to a upon pi t into sine of b by 2 t. And now I want to bring it in the form of sinc function. So we have the definition, we have this definition that sinc of x is equal to sin x upon x. So now here sin x, my x is b by 2 into t. 1 t I have, so now I'll multiply and divide by b by 2. So I can what I can do is I can write this as a by pi into b by 2 sine of b by 2 t upon b by 2 t, and this thing here is simply sinc of b by 2 t. So therefore x of t is equal to ab upon 2 pi into sinc of b by 2 t. So this is a very general case. In our question, our x of t was sinc of t. X of t was sinc of t. Now what we will do, we'll compare this and this. So comparing these, what I have is, first thing is b by 2 is equal to 1, which means that b comes out to be equal to 2. And second thing is ab by 2 pi is equal to 1, which means that, so this means that this b is equal to 2, so these two get cancelled and a comes out to be equal to pi. So now in our case we have a equal to 2 and a equal to pi and b is equal to 2. So how does this look? So this was our frequency domain or x of omega thing. So I'll just copy it. So this is what we had. So this a we obtained as pi and this b we obtained as 2. So this thing here is minus 1 and this thing here is 1. So in our case, this x of omega is equal to pi for minus 1 less than or equal to omega less than or equal to 1, and it is 0 otherwise. Okay, so now we had one by k integral minus infinity to infinity magnitude of x of t square dt. This thing here, this part I can write as, so this 1 by k will remain as it is, multiplied by integral minus infinity to infinity upon 2 pi magnitude of x of omega square d omega. So this thing, so these shaded green parts are equal. So this thing, this equality comes from Parseval's theorem. Okay, so now we are here. So therefore 1 by k integral minus infinity to infinity magnitude of x of t square dt is equal to 1 by k into 1 upon 2 pi. Integral this x of omega is valid from minus 1 to 1. So from minus 1 to 1, magnitude of x of omega square is simply pi square into d omega. So this comes out to be equal to 1 by k into 1 upon 2 pi into pi square into omega from -1 to 1. So this is 1 pi gets cancelled. So this is 1 by k into pi by 2 into 2. This gets cancelled. So what we are left with is pi by k. So therefore, our initial question, which was something like this thing comes out to be equal to pi by k. Is this question clear? Is it okay now? Do you have any questions in this? Any polynomial in any degree has infinite derivatives available. So therefore it is analytic. This was, I think, discussed somewhere, either in discussion forum or somewhere it was discussed earlier. I don't know. Yeah, but yeah, it is analytic. Okay. Now let us move on to the next question. Yeah, this is week 5's question. Okay. So this is question 12 of week 5. So it says that which of the following is true if Z transform of Xn and Yn have ROC Xn and Ry respectively. So it says that I have two signals X of n. Its Z transform is X of Z and its region of convergence or ROC is Rx, and Y of n, it is Y of Z and its region of convergence is R of Y. Okay, so now two properties are coming into picture here. First property is the linearity property. So what does linearity property says? So linearity property says that if I consider the linear combination of the time domain signals, that is if I consider A into X of n plus B into Y of n, then this will have A into X of Z plus B into Y of Z. Now what happens is this X of Z is valid for all Z that belong to Rx, and this Y of Z is valid for all Z belonging to R of Y, that is ROC of Y, right? Which means that if this is my entire function, for this to exist, this Z should belong to R of X and this Z should belong to R of Y, which means that Z should belong to R of X intersection Ry. But it is mentioned that it should belong to at least. And why this at least comes into picture? This is coming into picture because there might be or there may be some pole zero cancellations that will increase the region of convergence. Therefore, for linear combination A x of n plus b y of n will have a z transform as A into x of z plus b into y of z, and its region of convergence will be at least Rx intersection Ry. So for Ax plus By, ROC is at least Rx intersection Ry. So this is multiple answers correct. One was for linearity property and another one is for convolution property. So the next thing here we have is the convolution property. Of Z transform So in this convolution property, what we have is if x of n has Z transform x of z and region of convergence Rx, y of n has a Z transform yz with region of convergence Ry, then if I convolve x of n with y of n, then this will give me a Z transform as x of z into y of z. So now again the same argument should hold true which we made in linearity property, that this is valid for all the values of z that belongs to Rx. This is valid for all z's belonging to Ry, which means that this thing entirely will exist if z belongs to Rx and z belongs to Ry, which means that z should belong to Rx intersection Ry. Again we'll have a mention of at least Rx intersection Ry, and in similar way what we did in previous part or for previous option, we will say that this at least thing at least as there may be some pole zero cancellations. Okay. So therefore for convolution property, x of n convolved with y of n will have its z transform as x of z multiplied by y of z with region of convergence at least Rx intersection Ry. So therefore option D is correct. Is it clear? Is this question clear? Okay, so you want question 11 of week 3. Its detailed solution is there. Use properties of Fourier transform. I won't solve these questions whose detailed solutions are there. You need to use properties of Fourier transform. N into x of n, there will be differentiation in frequency domain. That kind of properties, you need to look at those properties and then try to read between the lines. But yeah, if I am not wrong, detailed solution is there. Let me check, because I checked it yesterday. Yes, the detailed solution is there. Sorry, it's not even a question of Fourier transform. It's simple a convolution question. So this is basically weak. This is the last question that I'm solving, which I haven't included here because these solutions are there. Let's see. So here given to you is h of n is equal to n plus a to the power n u of n. And what is your input? X of n is equal to cos of omega n. So then what you will do is your y of n will be equal to x of n convolved with h of n h of p of omega is not derived. You can easily find out using the standard definitions of Fourier transform. Can't you apply this formula h of omega equal to summation n running from minus infinity to infinity h of n into e power minus j omega n? This is the standard way of finding discrete Fourier transform or discrete time Fourier transform, not DFT, discrete time Fourier transform. Only that thing you need to figure out. That you can find out easily. And for that you can go and look at some properties of Fourier transform. Here you need to use two concepts. One is eigenfunctions. And second is you need to find out h of omega, which is equal to dtft of h of n. So now what is given to you is this thing here. This thing here, you are having h of omega. This you need to figure out. Now this h of n is equal to n plus a into a to the power n u of n. Now you just need to figure out this thing here. This you can write as n into a to the power n u of n plus a into a to the power n u of n. A to the power n u of n, this thing will have a Fourier transform of 1 upon 1 minus a into e power minus j omega. So therefore this thing here will have a Fourier transform of a upon 1 minus a into e power minus j omega, and this thing here will have a Fourier transform of something like t d omega into 1 upon 1 minus a into e power minus j omega. There will be some scaling here. I don't remember. There will be some scaling here that you need to take into care of. So you just find these two things and substitute here. You will find out your h of omega. If you still have a problem, just send me the solution that you have done. I'll check what's wrong there and then send you back. Just check what's wrong there. And if your solution is not matching, you should have just mailed Aniket also through that portal that your solution is not matching. Which week was this? Week 3. Okay. Are there any questions in the previous question that I solved? This one. Okay. I assume there is no other question. Let me move on to this question. Which of the following is not true about the poles of H analog S of Butterworth filter? So we had seen the equation that gives the poles for the Butterworth filter, which is Sk equal to omega c into e power j 2k plus 1 plus n by 2n into pi. So this is the definition, or this is how the kth pole is given. And here we say that this k runs from 0, 1 and so on till 2n minus 1. And then we say that we'll just take those values of sk's. So after finding this, we take only those sk values that lie in the left half plane of S plane. And why do we do that? We do this so that we can get a stable and causal filter. Okay, this is the aim that we wanted, and in order to achieve that, we will select only those values of Sk that lie in the left half plane of S plane. So if it is just lying in the left half plane of my imaginary of my S plane, then we can't have any poles on the right hand plane, which means that we can't get a mirror image for non-real poles about the imaginary axis. So, and we are asked that which of the following is not true. So therefore the non-real poles are mirror image about the imaginary axis. This thing is not true. Non-real poles are as mirror image about the imaginary axis. This is not true, and therefore we can't have this thing coming into picture. So this option is wrong. Next, let's look at the first option now. So first option says that the poles occur in the in a circle of radius omega c. So now if you look at this definition of Sk, so we have this Sk as omega c into e power j to k plus 1 plus n pi by 2n. So this thing here is simply angular part or complex exponential. So this simply gives angle of polar representation thing, and this thing here gives magnitude, and magnitude of Sk is equal to omega c, which is constant, and what changes is simply this angle, which is 2k plus 1 plus n by 2n into pi, which means that what's happening is this is omega c, and we are just moving around this radius like this. Something like this is happening, and therefore this simply tells us that SKs lie on a circle of radius omega c, which means that the first option is correct. The second option says that the non-real poles appear as complex conjugate pairs. So now if you look at the non-real poles, okay, something is wrong here. Yeah, so if just take this part and paste there. Yeah. Okay. So second option says that non-real poles appear as complex conjugate pairs. Now what we have is this H of n is a real filter. And since it is a real filter, we have this property for a real filter that non-real poles appear as complex conjugates. Therefore, the second option is also correct. So this is correct. This is correct. This we showed that this is wrong. So this is the option that we want. So this is okay. Let me write it like this just to avoid confusions. This is true. This is true. This is false. Then the last option is the poles are at an angle pi by 6 to each other for n equal to 3. So now let us just take the case when my n is equal to 3. We have our sk as omega c into e power j 2k plus 1 plus n, which is 3. So my n is equal to 3 upon 2n, that is 2 into 3, that is 6 into pi. So this is equal to e power j 2k plus, just a minute, 2k plus 4 pi by 6 omega c. So angle of sk is equal to 2k plus 4 by 6 pi. So angle of S0 is 4 pi by 6. Angle of S1 is equal to pi. So therefore angle of S1 minus angle of S0 is pi minus 4 pi by 6, which is equal to 6 pi minus 4 pi by 6, which comes out to be equal to 2 pi by 6, which is equal to pi by 3. So what is given to us here is the poles are at an angle of pi by 6 to each other for n equal to 3. What we obtained is the poles are at an angle of the poles are at an angle of pi by 3 to each other. So this is about the consecutive poles. Other poles will have a higher angle and none of them will have pi by 6 to each other because minimum angle is only pi by 3, and therefore this is also not true. So for consecutive poles, this thing is not true. This is also false. So this is also the answer that it is not true for the poles of H analog of S. Is this question clear? Okay, thanks. That's why I said, Professor Venkat, that send me your solution. I'll look at it and let you know what's wrong. So you mail me the solution. You can personally mail me on my ID and then I'll check it. Just for this question. I'm on leave, so I won't be able to check other things. So for this question, I'll go through once. Or you can also try and ask this query in the coming session, which is from 4 to 6. Directly to Professor Gadre or to Aniket. Probably he will also be present there. If they are unable to solve your query, then just mail me your solution. I'll help you out. Is it okay? Okay, thanks. Yeah. Okay, if there are no queries in this particular question, let me move on to the next question now. So the next question is the time domain differentiator h of omega equal to j omega for minus pi omega pi to pi for omega in this range of minus pi to pi. So I need to find the time domain differentiator of. So I need to find h of n. So this h of n is given by the standard definition is 1 over 2 pi integral from minus pi to pi h of omega into e power j omega n d omega. This is equal to 1 upon 2 pi. integral minus pi to pi j omega into e power j omega n d omega. So this is equal to j upon 2 pi integral minus pi to pi omega into e power j omega n. So now we can solve this integral as we are having this as product of two functions. So let's say this be the first function, this is the second function. So then I can apply the light rule. So I'll have this is equal to j upon 2 pi first function as it is into integral of second function, that is e power j omega n. Let me just write it appropriately. Integral e power j omega n d omega ranging from minus pi to pi minus integral from minus pi to pi differentiation of first function, that is 1 into integral of e power j omega n d omega d omega. So this comes out to be equal to j upon 2 pi omega into integral of this thing is e power j omega n upon j n from minus pi to pi minus integral from minus pi to pi e power j omega n upon j n d omega. This I can simplify as j upon 2 pi. Here I'll have pi into e power j omega pi, j pi n minus pi into e power minus j pi n upon j n minus e power j omega n upon j n squared from minus pi to pi. So now I have j upon 2 pi inside the bracket pi into this e power plus minus j pi n is equal to minus 1 to the power n. So I can write this as minus 1 to the power n plus pi into minus 1 to the power n upon j n minus e power j omega n, j pi n, which is equal to minus 1 to the power n minus e power minus j pi n, which is again equal to minus 1 to the power n upon j n square. So the second term goes to 0 and this first term now we have is j upon 2 pi 2 pi into minus 1 to the power n upon j n. So this j gets cancelled and this 2 pi gets cancelled, and now we have minus 1 to the power n by n. And this is true for n not equal to 0. So therefore this h of omega, this h of n is equal to minus 1 to the power n upon n for n not equal to 0. This is the answer which you have, which you were given in your, what do we say, options. Is this clear? Okay, great. Okay. Yeah. So if I have some time left, which I think I'll have, then I might help you solve the third question of 11th question of third assignment. Let's see how it goes. Let's see. Yeah, so this is the question 12 of week 10 and this is also multiple answer, correct? And it says that which of the following statements are true. First one is all causal systems are rational. Second one is all rational systems are causal, and third one is all causal and rational systems can be written as this form. So the third one is definitely true, which we have been using right and left. So this one is true. We are using this for representation of realizable systems. We are using it for every possible thing which we are having. So last one is true. Now the question is about the first two things. So first one says that all causal systems are rational. So let us try to build a counter example if possible for this particular argument. So for that, what we'll do is y of n is equal to sine of x of n, or let's say for that matter, let it be magnitude of x of n. This is causal. We cannot represent this as a rational system. Okay, which means that the first thing is not true. Second one is all rational systems are causal. So for that, let us consider a rational example of transfer function. So for that, what we'll do, let us consider this thing z. Let us consider this h of z as z plus half plus z inverse. Okay, so now we can find out its inverse z. So this will be h of n as delta n plus 1 plus half delta n plus delta n minus 1, or I can also represent it as a system or as a sequence, something like this, where this is at n equal to 0, and I also can draw it like this. This is n, this is minus 1, this is 0, this is plus 1. So I have a 1 here, this is 1, this is half, again this is 1, and this is something that we have at n equal to minus 1, that is h of n is not equal to 0 for n equal to minus 1, which is less than 0, which makes this as non-causal. But this system here, this is a rational form. This is a rational form, but the system is non-causal, which means that the statement that all rational systems are causal is also not true. So for both option 1 and option 2, we have these counter examples. We can build several counter examples here. We can say that this is log of magnitude of x of n. Then we have it as e power x of n, and several other examples we can build. All sorts of causal systems which can't be represented in rational form. Okay. Is this clear?
Yes, madam, it is clear.
Okay, thank you. Okay, so I'll give some hints for these three questions and then we'll solve the third question which you had a query about. So, okay, so the fourth question of assignment 7. So this was related to a question which was something like this. You were given h of s as 2 minus s upon 2 plus s, something like this was given. And then you were asked to figure out what's wrong and if this kind of thing is useful or not. So for a bilinear transform, so for this one, what you need to do is check if all the criterias for omega to omega, small omega to capital omega mapping is true. Then second thing you need to look at is magnitude of z equal to r, or magnitude of z at r equal to 1 is equal to uh, this will give me for trans 0, something like this. You need to check like maps to 0 or all the conditions. Just check all the conditions for mapping of this is true. There are 2 3 conditions which was mentioned in lecture. Just check that. The second seventh assignment's fifth question was related to Butterworth filter. So I think you were unable to figure out the last two options in which this was given, h of s equal to 1 upon s square plus root 2s plus 1 and these kind of things. So for that what you need to do is you have this formula for sk's. Use sk formula for n equal to 2, n equal to 3, then take only left hand plane and construct h of s as omega c to the power n divided by product of k equal to 0 to n minus 1 s minus sk. And when you do that you will be able to find out the expansions of that, and remaining options were just simply the properties of these kind of things of a Butterworth filter. Assignment 9, question 4. This was a question, I think I don't know if you people got confused. So this was a question in which you were given the analog domain frequency transform. Now I think you people got confused when they used this small omega as notation. It is simple analog domain frequency transform for bandstop filter. So whatever transform you have for bandstop filter, which is omega L as b times omega upon omega square minus omega naught square. I might have messed up the signs. Something like this you have. So just use it. Just use this transform, this kind of situations, this kind of transform for bandstop filter, and see which frequency component gets mapped to which frequency component. Simple thing. The similar thing was done for band pass filter and high pass filter in the lecture. You have to repeat the same thing. And if you got confused with this omega L and omega BS, this kind of thing, sorry, omega BS. So yeah, that transformation thing was for analog domain transform only and not for discrete thing. So these are the 3 questions for which I would like to give hints. Now let us quickly solve the question 3. I haven't solved it, so just be with me. I might make some mistakes there. Still, let's do it. Okay. Question 11 of assignment 3. Okay, so here it's given as, or what is asked is, find output of LTI system where impulse response h of n is n plus a into a to the power n into u of n, and x of n is cos of omega n, and then they wrote this as half of e power j omega n plus half of e power minus j omega n. And then what they did is something like this. So this y of n is simply equal to h of n. This y of n is equal to h of n convolved with x of n. This we can write as summation k running from minus infinity to infinity h of k into x of n minus k. So what we have is, we can simply substitute this x of n here. So we will have this as summation k running from minus infinity to infinity h of k into half of e power j omega n minus k plus e power minus j omega n minus k. Okay. Yeah, so now I can split it into two different summations. So I'll have this as half of e power j omega n is common or constant with respect to the summation. So this will come outside. Summation k running from minus infinity to infinity h of k into e power minus j omega k. And second term is half into e power minus j omega n, I can take outside, minus j omega n summation k running from minus infinity to infinity h of k into e power j omega k. So the first term, this thing here, this thing here is simply Fourier transform of h of k. So this thing here is simply dtft of h of k, and this thing here I can write as summation k running from minus infinity to infinity h of k into e power minus j minus omega k. So this thing here is simply dtft of h of omega, h of n, but now evaluated at minus omega. So therefore this y of n is equal to half of e power j omega n into h of omega plus half of e power minus j omega n h of minus omega. So this is what we have, and this is correct in this point, and now we need to figure out what is h of omega. So this h of omega is equal to the dtft of h of n, and this h of n is simply n plus a into a to the power n into u of n. Okay, so we have this thing here. Now what we can do is, this h of n I can write as n into a to the power n into u of n plus a into a to the power n into u of n. So the terms that are common are this one and this one. So what we'll do is, let us say that this is h tilde of n. So this h tilde of n is a to the power n un I assume that magnitude of A is less than 1. Okay, so this H tilde of omega, so this has a DTFT as H tilde of omega. This thing will be simply summation n running from, since it is u of n, 0 to infinity a to the power n into e power minus j omega n. This is equal to summation n running from 0 to infinity a into e power minus j omega to the power n. If magnitude of A is less than 1, this will converge and will be equal to 1 minus A into e power minus j omega. So therefore, this part here, let's say I'll name this as B and this as A, B of n, A of n. Okay, just be consistent with notations. B of n, A of n. So this B of n which is a into a to the power n u of n will have a Fourier transform as a of omega, which will be equal to a into h tilde of omega, which is equal to a upon 1 minus a into e power minus j omega. Okay, so this is what we are having. Now for h tilde of n, what we will do is, what we have here is h tilde of omega as summation n running from minus infinity to infinity h tilde of n into e power minus j omega n. Now let us differentiate this with respect to omega. This comes out to be equal to n running from minus infinity to infinity h tilde of n into e power minus j omega n into minus j n. So this is equal to minus j into summation n running from minus infinity to infinity n into h tilde of n into e power minus j omega n. So therefore j times d omega into h tilde of omega is equal to summation n running from minus infinity to infinity n into h tilde of n into e power minus j omega n. So n into h tilde of n, this thing is equal to n into a to the power n into u of n. So n into a to the power n u of n is equal to a of n. So this thing is simply equal to summation n running from minus infinity to infinity a of n into e power minus j omega n, which means that this is a of omega, capital A of omega. So capital A of omega comes out to be equal to j times d omega of h tilde of omega, which is equal to j times d omega of 1 upon 1 minus a into e power minus j omega. So this is equal to j times minus 1 upon 1 minus a into e power minus j omega square into minus a into e power minus j omega into minus j. This is what we will be having. Okay, so this gets plus here. Then we have this minus j into j. This becomes as 1. So what we are left with is a into e power minus j omega upon 1 minus a into e power minus j omega square. And now we can substitute this quantity and where did it go? This quantity in our expression. So therefore h of omega, okay, let me just add a new page, space here. H of omega is equal to a of omega plus b of omega. So this a of omega we have obtained as a into e power minus j omega upon 1 minus a into e power minus j omega squared plus a upon 1 minus a into e power minus j omega. This is h of omega that I am getting. What did these people give? Okay, this is what we are getting here. So they took out a into e power minus j omega upon 1 minus a into e power minus j omega common. This will leave me with 1 upon 1 minus a into e power minus j omega as it is, plus e power j omega here. Is this what you people were also getting?
Yes, madam.
Okay. This is for
Hmm.
the same thing that you were getting now. In this coming
Yes.
session, just mention Aniket once that there is some issue with question number 11's thing.
Oh,
Okay? Yeah, just
oh,
mention him once. Ask him
oh,
to check once and if possible give a detailed solution so that we'll get a
oh.
much more clarity. But yeah, this is the correct thing what we just solved.
Yeah.
Okay.
Okay.
Yeah. Okay. So this was all from my side today. If you have any further questions, then you can ask.
No questions,
Ma'am,
madam. Thank you. Thank
Okay.
you.
ma'am, few of the questions we mentioned in previous week, I think the third week, I think. So.
Third week
Actually, we know the
question.
answer, madam, but there is an ambiguity in understanding. Actually, I'm travel. We started now. Already, I posted in image, no, madam.
Yes, but it's not possible to solve these many questions, ma'am.
No, no, no. Just give the hint, madam. We will solve. Not a problem.
Okay, which all questions can you just quickly mention because I haven't opened the mail yet. Like I haven't opened the mail on my PC yet because it's on recording.
Okay.
Yeah, just
1 second,
mention.
madam. Let me check. Madam.
1 second. I think I have written it somewhere. Let me open my page. Assignment 3, na? Assignment 3, na?
Ma'am, I'm not sure whether 3 or 4. I'll give me a look at that. Madam, regarding this orthogonality, madam. Hello.
Orthogonality, Gram-Schmidt
The
procedure.
Yeah, yeah, we have done it, but the answers they mentioned is not clear, madam, because they are saying that is the right answer, but we are not getting a zero for every combination.
No, 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 no. So the okay, for the vector to form a orthogonal basis. Yeah, what you are saying
We are
is
not
correct. What you are saying is correct.
okay.
Yeah, yeah. So, since they have directly asked that which of the following can be orthogonal basis, they should lead to zero, and there shouldn't be a need to go for what do we say, Gram-Schmidt process.
Okay,
Yeah.
that you already explained in general tutorial
Yes, yes,
class, but
yes,
when we
yes,
apply this one, this is not justifying the what they have mentioned in
yes.
the
Now, just do one thing. Are you attending the coming session?
which one, madam?
From
Session?
4 to 6, Professor Gadre is taking a session.
Ah, yeah, yeah, I know, ma'am.
Huh, so that in that session, just do one thing. Ask
Okay.
him that when it is specifically mentioned that we need to look at orthogonal basis, why do we need to go for Gram-Schmidt process? The vectors itself should be orthogonal by definition.
Okay.
Okay, just do that once.
Starting 3 4 weeks, madam, we have a lot of doubts.
But they like assignment 2 they have given detailed solutions. One I solved whatever you mentioned.
Okay. Yeah.
I opened your mail, but there are 29 questions in 2 hours. Impossible to solve.
No, no, not required. For some of the questions we have the answers, madam. But in understanding the concept, there is ambiguity because the options are creating confusion while answering the question.
Hmm.
That we want to clear with you. That's the only thing. Doesn't mean that we don't know the answer. Ma'am, question 3 of week 5, madam. Is possible you look at that.
Question 3 of week 5.
Uh, can I read that question?
No, no, 1 second. I'll question 3 of let HL be the impulse response of the causal LTI system. Y of n equal to xn minus y of n minus 1. We wish to improve the stability of the system by making the following modification. The range of values, multiple possible, of alpha for which this system is BIBO stable is. Is this the question that you're asking?
Yes, ma'am.
Okay. So for that, you want your impulse
Actually,
response?
here second and third questions are interrelated, ma'am. The question is same. The way their answer asking the answer is different, ma'am.
No, no. The second
The
question, they
system
are
definition
asking
is
whether
same.
the system is BIBO stable or not.
Yeah, yeah.
So the answer is false. Now what they are doing is they
Yes.
are trying to reduce the feedback by introducing constant alpha
Okay.
such that you will get a stable system.
Okay. But they are asking range of values of alpha for which the stable system is.
Huh, correct. So now what are the possibility? Like how will you check the stability criteria? So try to apply the definition of stability criteria like absolute summability. It is a linear system. So just figure
Yes.
out its impulse response and then apply its what do we call absolute integrability criteria. In that you will get a and that should be less than infinity. So there you will get a range of alpha.
Okay.
Yeah.
ఇలా ఉంటే ఆ షెడ్ లో ఉంటాడు.
Okay, any other question?
Then without solving, can we answer this by looking at the question 2 of assignment?
Question 2 of which assignment?
2, madam.
Question 2 of assignment 2. 1 second.
So actually solution has given by writing sin A cos B.
This we have discussed earlier. There is an issue with this thing.
Okay.
The
That is issue. But we are unable to identify the options here now. That's the issue.
There was an issue with this question. Professor Murthy also had pointed it out.
Yes, ma'am.
Yeah,
But
I remember this properly. There is an issue. Like even in the solution, they have mentioned the frequencies will get added and subtracted. So clearly, the options this and this are the answer, but those frequencies are not there in the option itself.
okay.
Yeah,
So
there is an
whatever we
issue.
followed, that is the right answer. But
Yeah.
options
I
are
have
not.
solved a similar question in the tutorial. So just apply that. I mean, in the solution, they have given the steps which we followed, but suddenly something happened and they pointed out to a wrong option. Something like that happened.
Okay.
That approach is
Thank
correct.
Okay. Coming to the 7th question, madam. Theoretical analysis, this one actually. Same assignment.
Same assignment, 7th.
Yeah.
What is the advantage of working with phasors over sines and cosines?
Yes, ma'am.
Yeah, so exponential functions take up less space. No. Change of phase has a much simpler representation in phasors. Yes. Summing up sines and cosines directly is not straightforward. Yes.
Yes.
And complex exponentials are easier to visualize. No. So change of phase and phase has much simpler representation in case of phasor. So it's simply like multiplication by a constant, right?
Okay.
So that is easy to understand. Then summing up sines and cosines is not straightforward. You have to add up all sort of things that are coming into picture. But exponentials is simply a linear combination of exponentials, and that will give you some sort of signal. So it's much more easier in sines and in complex exponential to visualize compared to sines and cosines. So
Okay.
yeah, their answer is correct. It's fine. I think you should join their session now, Professor
Okay.
Gadre's. Yeah.
Yeah. Sure.
All the best for your exams, and thank you all for attending all the sessions that I have taken.
Thank you.
Yeah, thanks.